So we're given f of x equals 3x cubed minus 12x squared minus 15x, and we're asked to find all the x-intercepts of it. So we have three methods to find the x-intercepts of, hopefully we recognize this as a polynomial. So the three methods are by straight up factoring, like we would a quadratic, grouping, which we need an even number of terms to group, and using the possible rational roots. So I'm going to try the first two, grouping or factoring first, before I get into the possible rational roots. So grouping, I see that I have an odd number of terms, so grouping isn't even an option. Factoring, the first thing that I'm going to look for to see if this is factorable is to see if there's a GCF. So do all three of my terms have something in common? Well, I notice that all of them have an x. This has 3 x's, this has 2 x's, this has 1 x. So I can pull a single x out because they all have 1. And all of the coefficients are divisible by 3. So this polynomial, this cubic, ends up having a GCF, the greatest common factor, of 3x. So I'm going to start off by pulling that greatest common factor out, or factoring that greatest common factor out. So in factoring it out, what we're essentially doing is dividing each term by the GCF. So 3x cubed divided by 3x, the 3's cancel, I'm left with x squared. Negative 12 divided by 3 is negative 4, and x squared divided by x is x. And negative 15 divided by 3 is negative 5. X divided by x is 1. They cancel out, so I'm left with this. We are finding x-intercepts, so I do have that set equal to 0. In factoring out the GCF, what I'm left with is a quadratic. Now, we have all different methods to solving a quadratic. We could factor, we could complete the square, you could use quadratic formula, whatever you want. I do see that this one is factorable. It factors into x minus 5 and x plus 1, keeping the 3x on the outside. Now that I factored the quadratic, the whole polynomial, the whole cubic, is in what we call factored form. So I can take each individual factor now, set them equal to 0, and solve. And this will get me my x-intercepts. So all of these are just linear equations. That's the whole point of doing the factoring or the grouping, the possible rational roots. We're breaking that higher order, that higher degree polynomial into little linear equations that we can now solve. Do notice that since this is a cubic to the third power, look how many linear equations we are now left with, 3. That's not coincidental, that should happen every time. So now I just need to solve the 3 linear equations, divide by 3, I get x equals 0, add 5, I get x equals 5, and subtract 1, I get x equals negative 1. Here are my 3 x-intercepts.